Did you know that lakes can fart? Okay, so they don't quite fart like people do, but in a sense they can. You've probably heard about how cow farts contribute to methane emissions, and it's a similar thing that goes on with Arctic lakes. The same way that a cow's stomach acts like an incubator for methane, so do Arctic lakes in the winter. Now in the fall, these lakes are well mixed all the way down to the bottom. They're the same temperature, so wind can come along and stir them all the way down. But as we move into winter and the air cools, so do the lakes, and ice forms on top. But the lakes don't cool uniformly, meaning that the water at the top, next to the ice, is colder than the water at the bottom. And this causes something called stratification. Stratification is just a fancy word, meaning that these lakes form distinct layers of water that can't mix with one another. This stratification causes a problem for microbes that live at the bottom of the lakes. They normally rely on oxygen from the atmosphere that they consume, and then they produce carbon dioxide as a byproduct. However, due to stratification, oxygen can't move past the top layer of the lake down to the bottom where the microbes live. So these microbes have to resort to rely on other elements, which means they produce different byproducts, in this case methane. But the same way that oxygen can't move from the top of the lake to the bottom, methane can't move from the bottom of the lake to the top due to the stratification. So over the course of the winter, this methane builds up and builds up and builds up until we move into the spring. The lakes and the air warm, the ice melts, wind comes along and stirs the lake again, and all that methane that's been building up at the bottom of the lake gets farted or emitted into the atmosphere at once. Now that's what normally happens, but something different seems to be going on in certain Arctic delta lakes, which is where I come in. These lakes are not emitting as much methane as calculations say that they should be. What I theorize and am researching this is due to is the presence of dense plants at the bottom of the lakes, as you can see in the bottom diagram. By studying water column profiles, I'm seeing how these plants might be preventing wind from mixing all the way down to the bottom of the lakes in the spring. This is important because it allows time in the spring for oxygen to dissolve down and react with the methane. When oxygen and methane react, they form carbon dioxide. Carbon dioxide is a much less potent greenhouse gas than methane. This means that in the spring, instead of only emitting methane, these lakes are actually emitting a much less potent combination of methane and carbon dioxide. By researching and developing this new model of lake mixing, we as researchers can better estimate the amount of methane and carbon dioxide emissions coming from Arctic environments, which in turn allows climate scientists to fill in knowledge gaps about just how much greenhouse warming the Arctic is actually responsible for.